Hello. Welcome to physics. Today we are discussed about the Coulomb's law. This is a first lecture of electrostatics. Let us start one by one, step by step, the concept of Coulomb force. Basic concept about the Coulomb force. First, Coulomb force. Suppose that this is a positively point charge plus Q1 and this is a positively point charge Q2, right? And separation distance between both charge are, in the situations, both charge repel to each other as like this, right? Coulomb force on second due to first and Coulomb force on first due to second. This is a basic concept. And some basic formula about the Coulomb force. Coulomb force is directly proportional to product of both charge, and Coulomb force inversely square proportional to separation distance between both charges. This is the equation first and this is the equation second, and from equation first and second, from equation first and second, F directly proportional to Q1 times Q2 divided by R square, and F equal to K times Q1 Q2 divided by R square. K is a electrical constant value of K 1 by 4 pi epsilon naught, mean 9 into 10 power 9 for vacuum or air, right? Here epsilon naught is a permittivity of free space. And value of permittivity of free space epsilon naught equal to 8.85 into 10 power minus 12, right? Coulomb square divided by Newton meter square, and this value put here, and new formula of the Coulomb force Q1 times Q2 divided by 4 pi epsilon naught R square. This is a basic formula of Coulomb force, and some basic concept about the Coulomb force. Point 1. Coulomb force valid only point charge. This is a first criteria. Coulomb force only point charge. What is the concept of point charge? Concept of point charge, suppose that this is a charge object, right, and positively charged, suppose that, and second is a negatively charged or positively, right, and negatively charged. In the situations, size of the charge object, suppose that the size of object A and separation distance between both charge from the center of mass, suppose that R. In the situations, if size of the object is much more smaller than as compared to separation distance between both charge object, in the situations we can say both bodies work as a point charge, right? Means size of the object is much more smaller than as compared to separation distance between both charge. In the situation we can say body A and body B both are work as a point charge. This is a basic concept, right? And second criteria of the Coulomb force, like charge repel to each other, right, and unlike charge attract to each other. As like this, for examples, this is a positively charged and this is a positively charged, and in the situation both charges, this is a first and second, and in the situation both charges repel to each other. Coulomb force on first due to second along this directions, along this directions and Coulomb force on second due to first along this directions. This is a repulsive Coulomb force. And the second example, this is a negative charge and this is a negative charge. Both charge if negative, this is a first and second. In the situations, both charge repel to each other as like this. Mean Coulomb force on first due to second along this directions and Coulomb force on second due to first along this directions. This is a repulsive Coulomb force. Repulsive Coulomb force, right, due to like charge. And another examples, suppose that this is a positively charged and this is a negatively charged and both are opposite nature, then both charge attract to each other as like this. Mean Coulomb force on first due to second along this directions, Coulomb force on first due to second and Coulomb force on second due to first along this directions. This is a first charge and this is a second charge. And in the situations, value of F12 and F21 equal to each other, but directions just opposite to each other. Mean F12 vector and F21 vector, ठीक है, work as opposite vector, right. This is just some basic concept about the Coulomb force. And next, both charge, both point charge must be is at rest, right. Suppose that this is a point charge Q1 and this is a point charge Q2. In the situations, both charge must be is at rest, mean velocity speed of the both charge equal to each other, is at rest and also is at rest. No any motions with respect to frame of reference, no any motion. With respect to frame of reference, right. This is just some basic concept about the Coulomb force. And Coulomb force, this is a first charge Q1 and this is a second charge Q2. R separation distance, Coulomb force F equal to Q1 times Q2 divided by 4 pi epsilon naught R squares. And Coulomb force on Q1 due to Q2, mean F12 equal to Q1 times Q2 divided by 4 pi epsilon naught R12 squares. And R12 is a distance separation between first to second, and Coulomb force on Q2 due to Q1, mean F21 equal Q1 times Q2 divided by 4 pi epsilon naught R21 square, right. Here R12 and R21 equal to each other, equal to R. Means separation distance between both charge, right. And now we are discussed about the vector form of Coulomb force. Right. This is a first point charge Q1, and this is a second point charge Q2. Separation distance between both charge are, in the situations both charge repel to each other because both charge is a like charge, mean both are positive. In the situations Coulomb force F equal to Q1 times Q2 divided by 4 pi epsilon naught r squares, and for the vector form vector F equal to Q1 times Q2 divided by 4 pi epsilon naught r square and r cap. R cap is a unit vector. Here r cap is a unit vector. Its direction along the force, along the Coulomb force, and also magnitude equal to 1, and r cap equal to vector r divided by r, and this value put here. Then new formula of the Coulomb force mean vector F equal to Q1 times Q2 divided by 4 pi epsilon naught r cube, and here vector r. This is a basic concept of Coulomb force, right? Some basic criteria about the Coulomb force and attractive and repulsive Coulomb force. This is a basic concept. And now we are discussed about the Coulomb force in medium and also vacuum, right? Coulomb force in medium and fully medium filled, okay, right? In the situations, suppose that this is a point charge Q1 and this is a point charge Q2 and complete medium filled, right? Complete medium, this is a medium, and dielectric constant of the medium mean epsilon r, mean epsilon small k equal to epsilon divided by epsilon naught. Epsilon is a permittivity of medium and epsilon naught is a permittivity of free space, right? This is a dielectric constant of medium. Right, dielectric constant of the medium. In this situation both charges repel to each other as like this because both are positively, right, as like this. But value of Coulomb force medium equal to Q1 times Q2 divided by 4 pi epsilon r square because epsilon is a permittivity of medium. Right, and epsilon r equal to epsilon divided by epsilon naught, dielectric constant, and epsilon equal to epsilon naught multiply epsilon r, and this value put here right? Then new formula of the Coulomb force in medium, Fm equal to Q1 times Q2 divided by 4 pi epsilon naught times epsilon r times r squares, and Fm equal to arrangement of this formula mean Q1 times Q2 divided by 4 pi epsilon naught r square and 1 by epsilon r, and this value is a Coulomb force in air, Coulomb force in air or vacuum, right? Mean F0 mean F equal to Q1 times Q2 divided by 4 pi epsilon naught r square from previous explanations, right? And put here this formula, and new formula of the Coulomb force mean relation between Coulomb force in medium and in vacuums, Fm equal to F0 divided by epsilon r, right? This is a relation between Coulomb force, the relation between Coulomb force in medium and in air or vacuum, right? This is a basic concept of the Coulomb force. And suppose that partially medium field inside mean between both charge of the both point charge, then how to calculate Coulomb force, value of Coulomb force. Suppose that fully medium field between both point charge as like this Q1 and Q2, fully medium field, then Coulomb force Fm equal to Q1 times Q2 divided by 4 pi epsilon naught epsilon r squares, right? But if partially medium field, if partially medium field between both point charge, then how to calculate Coulomb force, right? As like this, suppose that this is a charge Q1 and this is a charge Q2, separation distance between both charge is r, and partially medium field as like this, thickness of the dielectric material plate T and dielectric constant of the medium epsilon r, right, or a small k we can say. In this situation, how to calculate the value of Coulomb force as a given diagram, right? Solve this problem mean Coulomb force as a given situations, because this is a separation distance between both charge, and the Coulomb force Q1 times Q2 divided by 4 pi epsilon naught bracket r minus t, right, plus t root k, mean k mean dielectric constant of the medium and whole squares. This is a basic formula of the Coulomb force when partially medium field between both point charge, then calculation of the value of the Coulomb force, right. This is a basic and main criteria about the Coulomb force. And some basic concept, basic formula of the Coulomb force. Suppose that JEE mains problem, suppose that this is a positively charged body as like this plus q, and second is a negatively charged body as like this, same amount minus q, and separation distance between both charged bodies is r, Then find out number of transfer electron from positively to negatively body, right? How to calculate? Solve this problem from the Coulomb force. F equal to, in this situation both charge body attract to each other because both are just opposite nature, as like this, right? Attract to each other. In Coulomb force Q1 times Q2 divided by 4 pi epsilon naught R squares, and Q1 equal to Q2 in the base of magnitude and equal to plus minus NE, right? And put here Coulomb force F equal to n square E square divided by 4 pi epsilon naught R square. In the situations n square E square equal to 4 pi epsilon naught R square times F, and n square equal to E dividations, and 4 pi epsilon naught R square F divided by E squares, and value of n equal to square root 4 pi epsilon naught R square F divided by E squares. And for the next step calculations, 2R divided by E square root pi epsilon naught F. This is a transfer number of electrons, value of transfer number of electron from positively body to negatively body. This is a basic concept, right? And next JEE main PYQ problems. PYQ problem. Suppose that this is a charge rod, uniformly charged rod, as like this, and positively charged distributed as like this, positively charged Q, and total length of the rod is L, and lambda is a linear charge density. From this end, next another point charge Q naught from R distance located at point A. Find Coulomb force. Find Coulomb force right on Q naught due to rod, due to charge rod, right? Solve these problems. Because Coulomb force valid only point charge from the Coulomb force. Coulomb force only point charge. In the situations, this is a charge rod, uniformly charged rod, and total charge Q, total length L, and lambda is a linear charge density, and this is a next point charge Q naught, right? From the x distance, cut dx thickness with dq charge, right? As like this, dq charge. This is a x distance, and the next point charge Q naught. Then Coulomb force between dq and Q naught. Coulomb force between dq and q naught. dF equal to k mean 1 by 4 pi epsilon naught dq multiply q naught divided by x square, and value of dq mean lambda is a linear charge density, lambda equal to dq divided by dl, right. Mean here value of dl equal to dx, because this is a value of dx, and dq equal to lambda times dx. This value put here, and the new value of the Coulomb force dF equal to k times lambda dx times q naught divided by x squares, right. And now total Coulomb force, and now total Coulomb force integration both side, integration dF equal to integration k lambda q naught dx divided by x square, and limit of dx with respect to x from r to r plus L, right, because this is a rod as a given situations, as a given diagram, because this is a r distance and this is a r plus L distance, because this is a L, right, mean length of the rod. In the situations F equal to k lambda times q naught integrations x minus 2 dx limit r to r plus L, right. And from the integration formula, x power n dx equal to x power n plus 1 divided by n plus 1. For the limit definite and indefinite integrations, using integration constant or using the limit of integrations, upper limit and lower limit of the integrations. And from this formula, value of Coulomb force k lambda q naught divided by x power minus 1 divided by minus 1, limit from r to r plus L. In the situations F equal to minus k lambda q naught 1 by x, right, r and r plus L limit, and using limit F equal to minus k lambda q naught 1 by r plus L minus 1 by r. And for the next calculations of this equations, k lambda q naught 1 by r minus 1 by r plus L, and k lambda q naught r multiply r plus L and r plus L minus r, and r plus minus cancel out, in new formula of the Coulomb force k lambda q naught L divided by r plus L, right, and q equal to lambda multiply L, and can be written as Coulomb force k q naught q divided by r times r plus L. This is a value of Coulomb force on point charge given as a given diagram, right, as a given diagram. This is a basic concept for the calculation of the Coulomb force, because Coulomb force valid only point charge. This is a first video lecture about the electrostatics, basic concept of the Coulomb force, superposition of Coulomb force, vector form, and Coulomb force in medium, and also vacuums, partially medium field between both charge and fully medium field. This is just some basic concept about the Coulomb force, and most important concept for the JEE mains exam, JEE advanced, and also NEET exams. This is a most beautiful YouTube channel, Vivek Physics. You are most welcome to here for every concept of the physics.